All right, I think we can go ahead and get started. So good morning, everyone. Welcome to today's webinar, Engineer Your CTE Course with Tetrix. Thanks for being with us here today. Just a couple quick housekeeping notes before we jump in. We'll be running a live Q&A session toward the end of the webinar. If you would, please use the chat feature for your questions. We'll either answer them at the end, or if I can catch them as they come in and they're pertinent and relevant at that time, we'll go ahead and try to address with answers then. Also, if you miss any part of today's webinar, we'll send all registrants the on-demand recording when it's available. And I'm Mary Metters. I'm your host for today. I'm a Pittsco veteran in North Carolina, 25 years here. I'm in the Piedmont area. That's the central part of North Carolina, Winston-Salem area. I'm in Lexington specifically. I work with our customers in North Carolina and Virginia, mostly helping CTE and STEM administrators and teachers with hands-on solutions for their students. And with us today also is Steph Forbes and Tim Langford. And Steph and Tim, if you two could just give a real brief introduction, we'll move on.
Absolutely. So Steph Forbes, I am the coding and robotics channel manager. So helping to manage the portfolio to ensure that we have the solutions and the tools ready to go to bring into classrooms that meet students where they're at, but also help prepare them for technology and their careers in the future. A little bit about my background. I have been in ed tech for 24 years now, primarily working alongside districts, helping them bring in similar programs to what we're going to be talking about today with computer science and robotics.
Welcome, everybody. My name is Tim Langford. My job with Pittsco is robotics application specialist. I get to work with our curriculum writers, our developers, with our robotics hardware systems and help them out with that. I'm a veteran of about 23 years with Pittsco, so you can tell we've got a lot of years behind all of us. So glad to be here today.
All right, thanks, Steph and Tim. So today we're discussing why teaching your CTE course through the lens of robotics is relevant for today's students and really specifically their future workforce opportunities. We'll have a quick review of robotics and STEM and CTE in general, and we'll explore considerations for building your CTE course around robotics and look at a sample robotics course with a manufacturing focus using Tetrix Robotics, and then of course the Q&A towards the end. But before we get started, I'd like to share an introduction to the sponsoring organization of this webinar. That's Pittsco Education. For more than 50 years, Pittsco Education has been a leader in hands-on learning rooted in CTE and STEM concepts. We help educators create learning environments that address all learning styles and help all students find success while solving problems and being creative and articulating ideas and thinking with their hands. Our programs help your students be future ready, possessing the soft and durable skills employers are searching for right now.
All right, so let's talk a little bit about the career outlook. And we like to kick this off to kind of set the stage of why it's important to engage students to start thinking about careers of the future, especially or in particular today in the areas of robotics. So we know that technology is advancing at a very rapid rate. And with that, we're also seeing the advancement of automation and robotics. And what this does is it's going to drive the demand for new skills and new jobs. When we talk about what are employers looking for and the skills that they're needing, we have 74% of employers are reporting that there's a mismatch between the skills they need and the skills that the workers currently have. And we know that technology is playing a big part in the types of skills that the workforce is going to need. And that we're facing a deficit in these skilled areas and across these industries. In that, where are the jobs of the future? We know that the jobs in that STEM realm, which is where robotics falls, is expected to grow at a much more rapid rate than other industries out there. So let's talk a little bit about robotics and what is robotics. And so this picture kind of depicts the different areas of a lot of times when we see it in school, it's about building a robot chassis and getting the robot up and running. But if we look holistically at the types of industries and skills and the type of technology that goes into robotics, whether that is a mobile robot, or something related to artificial intelligence and how do we make automation in the systems that we're creating smarter, including modeling. So what experiences do students need and what level of understanding do they need, and how to prototype and design in a 3D environment before they actually get into the prototyping. So from a holistic standpoint, what is robotics and in what industries and careers do we see this impacting and being a part that students will be that pipeline in that future workforce? So we talk about applications of robotics across the different industries. And, when we talk about robotics, it's an extension or a branch of engineering and computer science. We're seeing advancements, happen rapidly in several industries across the different career paths. And when we look at these, we can tie these back to pathways that you'll find in CTE programs. So in health and medicine, we know we have surgical robots that help with precision, agriculture and food. Robots now that can have lasers that pick weeds and can kill weeds in crops to make things more efficient, but also make it safer with how we grow and harvest our crops.
There's law enforcement robots, robots that are designed to go into hazardous situations and take the place of humans where that human could be harmed, or bomb disposals. There's transportation. Probably one of the biggest growing aspects is our cars, how we get around. They're becoming smarter and smarter and using sensors to become more intelligent and protect us and get us places faster and more efficiently. And then obviously one of the huge or big areas is manufacturing. There is all aspects of manufacturing where robots are beginning to play more and more prevalent role, whether it's actual product manufacturing or transportation of raw material from one area of manufacturing to other. So or packaging. There's a lot of areas in manufacturing that robotics is becoming more and more commonly used.
Yeah. And these are just a few examples of industries that are being impacted by robotics, but we know that industries and companies across the globe, they're leveraging new technologies and emerging technologies like the Internet of Things and machine learning, artificial intelligence, and this will change the way jobs are done and will also provide a springboard for new jobs to be created as technology continues to advance. And so as we think about looking across the industries, how do we bring meaningful and impactful learning that really allows students to experience it and see that application in areas of where robotics is currently helping industries move forward, but also, in the future, where will we see this happening? So why teach CTE through the lens of robotics? So what is it about robotics and why is it important, an important component of a experience or a career pathway? So we've talked a lot about careers, so helping prepare students for the careers. Where are the industries? Where are the jobs? What type of skills and experiences are they going to need? Whether they go to through a 4-year program, whether they go through a certification program, whether they come out of school with a career to work experience and they're ready to jump into the industry right out of high school, and also supporting a variety of pathways. When we looked at the different industries where we see robotics having the current biggest impact, you had your ag pathway, you had your manufacturing pathway, and so how do we develop these courses that kind of start them off and build that foundation and that springboard that gives them those foundational skills and experiences to help them understand, what is robotics, where is robotics, what are different applications of robotics that might engage and intrigue them to continue to further down to further their experience and learning in those areas. So a lot of time in states we'll see robotics pathways happening under the manufacturing pathway, or the computer science and IT pathway, or that STEM and engineering pathway. So when we think about that intro to robotics course, what is it from that foundational level that needs to be happening to help support them and prepare them for those next steps?
And one of the huge benefits that you can get through robotics is the way that robotics can engage the wide spectrum of students. Students that learn in different ways. They typically can be engaged in some form or fashion through a robotic venue. And then the skill set that you begin to develop through robotics, there's those skills that are not necessarily technical in nature, but also the soft skills. And I like the term durable skills, skills that are go above and beyond what typically we talked about the mismatch that employers are seeing as far as the skills that they're seeing and what they really need. And I think this is where part of that comes into the robotic students are learning those problem solving skills, those critical thinking skills, those skills that employers have a harder time teaching. Robotics naturally kind of focuses on those, and those are the durable type of skills that transfer across in the different areas that they might come into in whatever pathway that they choose. And then also what's I think important in the fact of why robotics is so effective in teaching this kind of a class is the fact that kids need a reason why they want to learn. And when you couch this challenge or whatever in the terms of a competitive type event, all of a sudden they're engaged and they have that reason of why they want to learn, because they want to win. We're a competitive type species. We like competition, whether it be in sports, whether it be at the county fair and our who's making the best pie. We have a lot of different areas that we like to be competitive in. And so this is a natural area for kids to be engaged with, and that gives them the reason why they want to learn the skills that you're giving them in the robotic platform.
And that community and collaboration, when we talk about competition, giving them that space and that outlet to work with their peers, to develop, as you mentioned, Tim, those durable skills that how do I work effectively with a purpose, with a group of students, and finding that place of students that have similar interests, and how do we come together and solve a problem in a meaningful and impactful way. So we talk about building your course, building a robotics course for CTE. So specifically, as we start to talk through, we're going to really focus on that intro to robotics. So that level 1 robotics, where students with any interest in any background can step in and be successful. So when we think about, what needs to happen or what needs to make up your CTE course when teaching that intro level of robotics is, what's your purpose? Is there a specific pathway that this course feeds into? So if it's manufacturing and there's a certification at the end of it, what is that? What are those primary skills and experiences that students need to have and have developed to kind of move them along and prepare them for that next level, that robotics 2, or whether it's a certification. And then the types of experience, that hands-on kinesthetic, what is it about the systems and the way that the different parts and pieces work together that is important for students to have and also understand as you're building out the course, and also teacher support. So we know a lot of times, it's depending on whether your state has a course blueprint or you've been tasked with building your own robotics course, having those resources that help define and outline, what are those key objectives and how do I go about teaching them, and how do I help bring these experiences into the classroom in a meaningful way? What do those resources need to like? How do students like to learn? And what's the best method to ensure that we're meeting all of the different learning styles and objectives? So now we're going to jump into, we've been talking a lot about robotics and different industries and, things to think about as we're putting together a program. And so now let's dig in and let's take a step through and kind of walk through what could that robotics course look like if this was a primer or a prepper for a manufacturing pathway.
So why would robotics be important in manufacturing? Obviously, there's a lot of areas that robots can help us out. And one of the primary areas, probably one of the first things that people think about is safety, whether it be injury through just hazardous material or injury through repetitive actions. Robotics can address that, whether the environment is loud or the environment, the air is not right, or heat or anything. A robot can obviously perform well in all kinds of environments that might be hazardous to a human being in manufacturing. Then there's speed. If anybody's ever watched an expert that is very good, a craftsman at their job, it's a marvel to see how they seem like they have no wasted motion. They seem like they flow from one action to the other, and you turn around and all of a sudden they're done. And that efficiency and that ability to be consistent and speed, that's something that a robot, if programmed properly, can duplicate, where a human has a lot of years to be able to get to that level where they can produce at that kind of consistency and reliability. Then there's just the fact that robots can work a lot longer than we can. When you're lifting 50 pounds every day from one spot to the other, you got to rest every once in a while. A robot can address that and can be productive in an environment like that a lot longer than a human could be. And then obviously I mentioned efficiency, and then scalable. The fact that, you can, whether it be the task be small or the task be large in scope, robots can be adjusted or created to address that in whatever kind of a method that you need. And then just employee morale. I mean, when you think about the fact that sometimes when you repetitive and dangerous jobs can, weigh on a person's mind. And when you think about, I'm dreading to go in and do 8 hours worth of work, lifting from one thing to another. But if you've got a robot that you're controlling that does that manual labor, then all of a sudden it's a lot easier day to think about. So it has a place in actually creating a good mindset for the employee and addressing the morale issues. There are specific things that manufacturing needs. Obviously, as the world is changing and our focus is becoming more conscious of the dwindling raw material and resources, the ability to effectively and efficiently use those resources becomes more and more important. And again, robots are one of those areas where we can minimize waste, we can increase the efficiency, make a faster workflow. And that's something that just about all manufacturing are looking at in order to maximize their time and be more efficient and more productive and more profitable. Obviously, then one of the things that is huge is a repetitive task. Again, as humans, we have a threshold of tolerance toward repetitive task, and robots are perfectly designed to address that and be able to do things longer, repetitive things with less burnout and or no burnout, where a human might not be able to do that. Safety, we mentioned safety again. It's primary. You know, if you've got an employee that's injured, that's an employee that can't work, regardless of just the fact of, you know, them being injured. You never want to see that, but that's one less resource that you have. So if you've got a robot that can step in and not worry about getting hurt, then that's again a huge concern for an employee or a manufacturer. And then the fact that they can be more consistent. There's less chance for error through fatigue that a robot would have. So again, it addresses the fact that less errors means I'm more profitable, more productive, and becomes more efficient all for our manufacturer.
Thanks, Tim. So what kind of you shared a lot about what you know, why robots in manufacturing. Can you talk through a few examples of what that actually looks like from the lens of when we think about what the students need to be learning, and how do we introduce and teach students to specific concepts around the systems and types of mechanisms that would be used in a manufacturing facility?
Sure, there's a lot of different areas where robots can address kind of specific types of work, whether it be a lifting robot and or a pick and place type robot that actually sorts, or something that has to raise something repetitively from one place to another in an automated line. There's navigation robots that are designed to move material from one stage of manufacturing to the other, whether it be raw material to the first manufacturing process to that finished good that comes off the line, and it takes it to a warehouse facility that stores it ready before it goes to the final user. And then the actual robots that are on the production line that actually do a specific job, whether it be welding a specific joint in the process of putting together or assembling different types of material, or a robot that does a paint process. There is a lot of different types of robotic devices that can address those types of needs in manufacturing of all types.
Thanks. So we've talked a lot about why, you know, why robotics in manufacturing and what type of robots or technology is happening in that industry when it comes to automation. And so let's reverse engineer and talk about and kind of talk through, you know, what does that course need to look like? So if we know this is the area of, you know, the why robotics in manufacturing and the types of robots and technology that are being used, what is it that needs to be happening in a Robotics 1 course to kind of introduce and prime and prep the students? So we know that they'll be working alongside of robots. We know that they will be controlling and maintaining different robots. We know that there'll be some human computer interaction. And so there needs to be a certain level of understanding of what's happening and how these systems work together in order for humans to be able to work alongside of them. So let's take the Tetrix Max portfolio and talk through how can we, similar to the robotic side, how can we take this and build a course that's helping to be that primer? And so, you know, one of the things we talked about is that purpose. So are we wanting to build this for a pathway? Is this more for a competition focus? You know, what types of experiences do we want this to be more heavy on the engineering? Do we want there to be computer science? Do we want there to be a mix? What level of teacher support is needed? And then what are the outcomes that we're looking? So helping prepare students for those next steps in the career, creating curiosity and engagement in pathways, understanding industry needs, and then always building those 21st century skills that are so critical. So when we look at the kind of the portfolio of what makes up Tetrix Max, so in that reverse engineering, really starting with that engineering foundation. How do things go together, right? How do parts and pieces go together that then make up these pick and place robots, or a robot that's going to navigate a warehouse and move packages? So you have your Tetrix Max Engineering Mobile Robotics. So that would be kind of that foundational curriculum that would enable teachers to kind of facilitate that introduction to engineering design, the introduction to how different systems work and how different mechanisms go together for a purpose. So it provides students some step-by-step instructions that helps them get up and running and be successful quickly. We also have the Tetrix Builder's Guide, which if for that purpose, it would be kind of before we jump in and start learning about the engineering side of things, we could have them just follow step by step and get a robot build and take a look at it, and then use that as a springboard into moving more into that engineering side of things. We talk about robotics being a blend of engineering and computer science. And what's that what's our purpose with that? So Tetrix Virtual Robotics, which would be that computer science and coding side. So identifying, what programming languages are important for students, or what programming language do we want to incorporate into this type of experience. So with Tetrix Max, it would be working through a simulation and a physical robot experience. So the students would use Tetrix Virtual Robotics to start building those foundational skills and understanding how to code in C, how to code efficiently in C. They'll work like an engineer, so they will actually simulate the robot performing a task, and then be able to move it directly to the physical robot and see it working in the real world and starting to refine. So really building that real world experience of how an engineer works. We know that it's important to get to that project-based, that more open-ended side of things. And so that's kind of where that progression of Tetrix Max Comp in a Box is really where it supports that blending of what students have learned in the engineering mobile robotics, as well as Tetrix Virtual Robotics. And then it puts them into a project-based experience where they're truly working through the engineering design process. And this is where the connection to careers and competition really comes into play. So kind of that holistic, from a content level experience, what that foundational Robotics 1 course could look like. Tim, do you want to talk about the actual hardware? Because we've talked a lot about the content, we've talked about the software, but that experience and that physical component with a build system and the controller really is what allows them to experience what they're learning.
Exactly. You have to have something from again, we talked about hands-on learning being so important, and that physical manifestation of what they're actually trying to do, and you have to have something to do that with, and the Tetrix Max build system comes in a lot of several different formats that allow and facilitate that. We start with our Max dual control robotics set, which would be a specific set of hardware with two main focuses. You can start with just a RC or remote control type of devices, and just the amount of hardware that you need that they can accommodate what you are asking them to do with the build guides, but also enough hardware that allows for exploration when you give them the challenges, but also gives them the type of thing so that you're not giving them pat answers. They have to actually learn the engineering aspect and say, how can I actually build this type of device or mechanism or manipulator or end effector that accomplishes a certain task. So the sets themselves has enough material that they can accomplish those tasks, but yet it's not, again, pat answers. Then we have sets that are specifically designed for competition. We talked about how competition is important in the fact that it oh, I forgot. I totally overlooked RC, remote control, but then we have in that dual control set our microcontroller Prism, which allows for the computer science aspect of it and the programming aspect of it. So they can move from the remote control aspects to fully autonomous type devices and learn about the programming side of things. So that's also part of the max dual control set that they would get. And then we can go into the competition sets, the sets that are really designed with specific types of competitions in mind that facilitate, again, that competitive spirit, sets that have a little bit more in scope as far as the materials that comes with them. Again, it could be for urban search and rescue, could have an RC focus. For the First Tech Challenge, it could be more focused toward an autonomous type of solution, but both sets are specifically designed to address a couple of the major robotic competitions that are available to students in both the middle school and high school venues. So those are some of the things that, from a hardware perspective, are going to enable the students to be successful in a robotics course.
So kind of gave an overview of some of the curriculum. So we talked about the engineering mobile robotics. So building those foundational skills, getting students comfortable with design and how a build system works together and how systems are created. Talked about Tetrix virtual robotics as that primer with the coding, getting them comfortable and familiar with how they control a robot and from an autonomous standpoint. And so kind of that second or that third layer would be the Tetrix Max curriculum, Comp in a Box. So this is designed, this is a curriculum that's designed to be kind of twofold. One, it introduces students to robotics through the lens of careers. So there's different careers that are included in the different zones, and we'll talk about those. But it also presents robotics in the landscape of competition. So it's kind of a dual role curriculum. Students will learn about different types of competitions that they can be involved with or that can be happening in the classroom. What it comes with is a student guide to kind of help guide them through the engineering process and the different components that make up competitions. It also comes with a teacher resource that will help provide kind of that scope and sequence for how you lay out the curriculum. It comes with a really easy to put together arena, as well as some obstacles and different components that you can include in the arena to help support the competitions. So there's 3 zones. The first 2 zones really focus more on the RC, so that's more of the engineering side. How do I create systems that go together, and then how do I control them, and kind of making that observation of the trade-offs in design in order to complete an objective. And then zone 3 really focuses on that autonomous side of competitions, as well as robotics being used in industry. All the activities and competitions are open-ended. So no step-by-step building instructions. This is really where the work the students have done prior to come into play, and they go through the full engineering design process, very similar to how an engineer would work, to meet an industry objective, but also be prepared to compete in a competition. So let's dig a little bit deeper. So I talked about the 3 zones which make up the curriculum, and the first 2 zones being more focused on the RC. And since we're talking about how can we put an Robotics 1 course together with more of an intro or a connection with that manufacturing pathway. So zone 2 is all about meeting the needs of industry. And so when students are introduced or when they start this particular unit, they are provided kind of a background into how robots are being used in manufacturing. And then they're put into the kind of the seat of being in a career where there's a specific company that's looking for a specific type of robot to do a specific task. So going back to what Tim talked about, what are the needs from manufacturing? And so they're placed in that. And then there's also a competition at the end. And so they go through the research and design process, where they're going out and researching, what types of systems are needed. How do I start developing different systems to be able to complete these different types of tasks? Coming up with kind of a sketch or a prototype design, And then they start moving through the different activities. So this zone is broken down into 3 activities where they focus on 3 different specific systems that will be needed to complete both the objective of the challenge, but also the objective of the competition.
So those 3 activities are kind of broken down again into kind of main sections, and they're progressive in nature. Obviously, you're going to start from the beginning in the basics of just a chassis with the drive system, so that they're going to learn through that how they can navigate from just one point to the other. And a lot of the things that they're going to learn are again, some of those skills that we talked about earlier, as far as the employees are really looking for, is, okay, how do I identify a problem? Where do I actually recognize what the challenge is, and what are the aspects and the criteria and the constraints that go along with that, and being able to acknowledge that, and then start to think that, use those critical thinking skills to, okay, how can I solve that? So they're going to be walked through that as they address these different aspects of the different systems. Each and every one's going to have a similar process, so that they're reinforced and all that, but they're going to start that with the navigation system. Then they're going to add to that. Again, it's progressive in nature. So they're going to build on what they just did with the navigation system by adding the lift system. And they're going to explore the different options, the different types of lift systems, and talk about efficiencies and minimums and maximums, and what it takes to accomplish the actual challenge as it's presented. We talked about constraints and criteria. All of this stuff is really going to begin to come in play when they start making specific types of devices to really focus in on a specific type of challenge. Once they get that all resolved with the navigation system, and they've added the lift system, then they're going to look at that end effector, that gripper, or that scoop, or something that is going to be that culminating piece that's going to go on that mechanism that they've built, and really make it specific to a very targeted task. Obviously, when we talked about the different types of robots for manufacturing, the more targeted the task, the more targeted the robot becomes, and specific to be able to accomplish it, that really target that very specific task. So they're going to learn about that as they begin again to build and end up with this culminating robot that has this end effector or gripper or scoop. And there's a specific activity that addresses that allows for that. Then finally, to bring it all together, once they've gone through those 3 different phases, you're going to give them a competition. And this is, again, one of those things that I really like, because it mirrors that real life thing that manufacturers face all the time. For those that don't know, RFP is request for proposal. And RFPs are things that manufacturers get all the time from their customers that they have to respond to, that have a specific challenge that they want a specific robot to do. So they have to think about that the same way that a manufacturer would. And it's all part of this culminating activity where a warehouse company has to develop a certain robot to stock the shelves. They're given the criteria and constraints to go along with that. They have to respond to that with an RFP, and then actually back that up with a robot that actually performs the task. And then they do that finally in a competitive type of environment, so against their peers. So again, who's going to win the competition by having the best robot and the best RFP for the manufacturing? And that's something that real life manufacturers do all the time. Not everybody is the only one that responds to an RFP. Sometimes they're very competitive in nature, because there's a lot of company that wants business. So, and a lot of companies compete against each other for that small slice of the pie. So it's very real world in that aspect, in the same type of a competitive type environment. And we found that students are engaged and respond to that. This gives them that incentive to, again, come to class every day and stay after class sometimes, because they get so engaged and they want to win.
Thanks, Tim. So just to kind of bring it for full circle and bring it back to why we're here today. And why do we teach robotics or CTE through the lens of robotics? And so we've talked about preparing students for the STEM careers. We've talked through different industries and different ways that you can build an intro to robotics 1 course to create that excitement, but also to help prepare students for competitions. When we were talking through and Tim was sharing a lot about what was happening in those activities, those are all of the skills that, the same skills that we're using or wanting to students to develop to be prepared for industry are also the same skills that they're going to need to be prepared and successful in competitions. And so how can we build a course that helps students do both? And also introducing them to different industries where there could be a potential CTE pathway. So we talked about agriculture, health and medicine, manufacturing, in the engineering side of things. And so, how can we build these courses that provides them the biggest lens and the biggest real world experience to see this in action and application? In that Comp in a Box, one of the other units is around search and rescue robots from the autonomous standpoint. And so, they're going to get experience with manufacturing. They're going to get an experience understanding and exploring how robots can help in natural disasters and help with recycling and waste with a sorting robot. And so the more opportunities we have to really expand that vision and understanding with students, the more opportunities we're going to have to fill that pipeline that we know where we're already facing a shortage. And with the rapid pace of technology, we know that that's going to be more and more where those careers of the future are. And then talking about all students, right? Students from different diverse backgrounds. How can we develop a course that enables students regardless of their background or prior experiences and gets them curious and excited, where they can be successful and want to go further and explore and develop those 21st century skills. And then those durable critical skills that Tim, talked about, being able to collaborate and problem solve and be able to work together to meet a specific objective, really allow that to happen in practice with students. And then preparing them for the competition. We know there is a ton of competitions out there. So how do we really prepare them to be successful and to be ready for when they walk in, whether that be through the First Tech Challenge, where they're going to be put in a scenario where they're going to have to be able to not only program but design and have that human interface with driving, or that urban search and rescue, where the design of the robot is different.
We talked about one of the things, and I think that this is the strength is, again, in the past, learning a lot of times has been theory. You give a student a book, or you stand in the front, you do a lecture, and they're expected to learn that by rote. But one of the strengths with this in a hands-on activity is you actually have a physical manipulative that the students get, they have to work through, and they see immediate cause and effect. And it's an activity that they can again embrace and see. So it's not just reading a theory, it's putting theory into action through a device. And I think that's where the power, one of the huge benefits this brings to the table, and allows those different types of learning that we know students have. It embraces that and gives them the opportunity to address it in a way that's meaningful for them. And at the end of the day, that's what's important, right? I mean, if the student isn't engaged, it doesn't matter how intelligent or non-intelligent they are, they're not going to learn. So that's the key behind all of this, is you're giving them that opportunity and venue that they can embrace and become engaged with. And that's where the true learning is going to happen.
Hey, so awesome, Tim and Steph, you guys did a great job. we just had, this is good timing, Steph. We just had a question come in about the size requirement for competition in the box, and I have a feeling it was more related to like how large that arena is. And then the follow-up, which you have already addressed, was related to how comp in a box, competition in a box can be used for supporting a competitive, like a Skills USA urban search and rescue team. So I think you've kind of addressed that, but what can you say about the physical size?
Tim, do you want to take that?
Sure. I mean, this is one of the beauties of the comp in a box because it comes with a set of 2x2 tiles. You have enough material to create a 12x12 space, or you can scale that back. You could make anything from obviously a 2-foot tile. It doesn't give you a lot of room, but if your robot's not very big, then it might be enough room. But you could put those tiles together in any formation that you want. So you could be a square, you could make a maze. There are walls and a specific plastic piece that we actually designed and made to go with the mat so that it sits in the corner. And you can design a space anywhere from, like I said, 2x2 all the way up to 12x12. If you got 2 comp in a boxes, you could put them together. You could make double the size. So you really can build the type of space that suits your available space that you have. Here in R&D, I have a table that I made that's actually 8x8. That's on rollers so that I can move around. It's not quite as all the way on the floor, so the old man I don't have to worry about bending all the way over. So again, they're really adaptable to different areas and spaces.
Yep, perfect. Got a couple more. These are just coming in. Let's see. I'm going to read this one verbatim. It says, I just realized the slides. Oh, wrong one. Let's see. If my school had a Pitsco Tetrix kit, is there a comp in a box with the simulation piece alone?
Yes. So good question. So yes, so you don't have to buy everything all together. You can, if you want that Tetrix virtual robotics, that simulation component in curriculum, you can purchase that license separate for however many students that you want. And we've seen it done in a few different ways. Some classrooms want it where each student, even if they are working in small groups, they're working through the simulator and they're coding. So every student is getting that coding experience. And then once they test it and verify it in the simulator, then they come together as a group and work with it on the physical robot. So it depends on, what's important in your classroom. Is it, having all students having that experience and developing those coding skills, or is it more of that team experience where you have, one or two students that are those primary coders? And then comp in a box is totally separate. It's something that you can add on. You get everything all together, the whole competition set, the student guide, and the teacher guide. The language is C-based, so they would use the Arduino IDE or web editor when they're working with pushing code to the physical robot. And the way that it works is that the students are able to save out a file that is the same code that they've built in the simulator. They can open up the IDE or the web editor, open up that sketch and put it directly on the robot. So again, working very similar to how an engineer would work and test. Good
And
question.
I just want to build on that just for a minute, because I think one of the things that we tend to overlook for a simulation type environment is basically what you're doing with a simulation is you have this perfect world. And in that perfect world, everything is going to give you this consistent behavior. So it's really good for learning the basics of coding and stuff, because everything is going to happen in a expected way. But we all know that the real world is not that way. It's not perfect. And so one of the powers behind that is they move from that simulating environment with something that they were very successful with, and they go to the real world and it doesn't work exactly the way that they behave because the real world is not perfect. All of a sudden it opens up this really rich area for discussion that says, okay, why is it different? What is it about the real world that is not perfect like it is over here in the simulation? And it allows for a lot of exploration and actual learning when they start to think about friction coming into play or slippage and all of the things that we take for granted every day because we're in it in our natural world, but it's not perfect. So there's so much opportunity for learning when you go from that simulated perfect world to the real world.
Yeah.
I'll get off my soapbox. Sorry.
Thanks, Tim. Good soapbox. Hey, so Tanya asks, she says, I'm a first-year CTE teacher. I have a classroom set of Tetrix Prime, which we've not discussed, so we'll side conversation here. What are the limitations with Prime versus Max? She says, also, I would love to find more resources, lessons, projects. Is there a specific place to find these? I'm wondering if maybe we can't touch base with Tanya after the webinar and help get her in touch with her
Absolutely, Tanya.
education advisor. So Tanya, just hold out for that. But her question about Prime versus Max compatibility, that was actually a previous question as well. So can you all address that?
They
Yeah,
are
so-
compatible.
Yeah.
They are compatible. You can use them together, but the main difference between is scale. Again, Prime was specifically designed with a few things in mind to help facilitate a little quicker build. It's got a little less power, but again, that generally makes it a little bit more appropriate depending on the focus. Maybe in a lower grade, but it still can be, again, depending on the focus, used at upper grades as well. So it's just a little bit different scale, but they can be used together.
Yes, correct. And there are several different educational resources that will help you be able to plan your course and provide those resources. So definitely, Tanya, let's connect so that we can help understand what you're wanting to do in your classroom and kind of what your focus is, so we can best recommend the different curriculums and resources that we have.
Yeah, perfect. Thanks. Thanks, Steph. So another question is, this is a great question. So really outside of the box, when teaching business or entrepreneurship courses, building websites for small businesses as a component, what components could Tetrix Max contribute to this curriculum?
Ooh,
That's a big one.
That's a good one. I think from that landscape of in going back to the RFP, is how would you market and how would you take a solution or a physical Tetrix robot? How would you be able to market and sell it? I think of that from the entrepreneurial landscape. If I'm a small business and my job is to develop robots for different industries or different manufacturing industries, what does that website need to look like? And what do I need to talk about? And how do I need to talk about it that's relevant to that market? And what type of images do I need to have? And, so taking it from that landscape of, if we're just, speaking specifically to this manufacturing connection, how would I sell these robots? If I needed to make X amount of money, how many robots do I need to sell? How do I talk about it? Do I allow quotes on the website, or do you have to call for, a discussion? So there's all sorts of connections of, which goes back to whoever's building the website has to have a certain level of understanding about the system and the robot to be able to market and sell it and be able to talk about it and also to service it, right? So what resources do I need to have on my website so that a user can go and have FAQs and things of that nature? So all, those are just some of the things that popped into my head when that question came up.
All of the Tetrix material on the website usually have CAD files available for download in a step format, so that if you have a CAD program, you can build virtually with Tetrix, just like you would in the real world, like I said, and then those could be exported into images, whatever that you need for that website. So there's a lot of supportive material that would go along with what Steph just said and be able to create the visual effects that you might need for a website.
Yep, perfect. Hey, kind of along the same lines, this is quite good too. Do you have a 2-year course sequence mapped out with curriculum and materials / kits? If so, is curriculum also digital for students? That's from Anna. And Steph and Tim, I think we have just less than 5 minutes. We have one more question after this as well that I'd like to try to address.
Sure. So we have the Robotics 1 course mapped out. We're working on Robotics 2. And that will be a mix of different platforms. So it won't necessarily just be Tetrix. It will be something like Arduino, where you're starting to get into students getting under the hood of what's controlling their robot. And how do you take an Arduino board and learn about resistors, and creating schematics and things of that nature, and learning about volts and watts, and how do you build that mechanism or that controller, that microcontroller that's under the hood of all of these big industry robots, giving them that foundation. And then working into something like a PLC, where you're industrial manufacturing controllers and things of that nature. So 2-year course, and the answer to your question is yes, everything will have curriculum. Some of it will be paper-based and some of it will be digital as well. But yes, working on a 2-year course for sure.
Great, thanks, Steph. So Stacy, I love this. Stacy says Pittsco is my go-to for all creative robotics materials. Thank you, Stacy. Can you only purchase switches, wires, and motors separately?
Yes.
That was easy.
Yes.
Stacy, we will connect you like the other participant earlier. We'll make sure to connect you with your contact at Pittsco to help you find exactly what you need there.
There are some different options though. You can get a group of motors. I mean, you can get some of the things separately or in packs, depending on how you need them. So again, one of those, if you reach out to your advisor and you have a specific need, please don't be afraid to say it, express it, and they might be able to help you find exactly the purchasing option that you need to be able to supplement your material.
Yep, perfect, Tim. I think we should probably bring this in for landing. We're down to just a couple minutes.
So there is one more question. Where do the CAD files fit with this curriculum? So the CAD files that you're talking about, Tim, how do those fit with this curriculum?
Well, it could be in a couple different ways. Again, if you're trying to if you think about that, going from the simulator to the real world, a lot of times it's more efficient if you can CAD an item up, or to be able to, before you actually build, to be able to save time and make resources. So that could be one way it could fit in. It could be another way that you have you have actually built a physical robot and then you duplicate it because you want to market that robot in the RFP as part of that, to be able to sell your product. So you could use the CAD files in that form as well as part of that curriculum. So they not everybody's going to use them, but again, they're there and available for you as part of the resources and support material that Pittsco provides. Did that answer the question?
Yes.
All right, thanks you all. So we will be sending the recorded link out to everybody. And what you see on the screen here with the QR codes and those links, those will be included as well. So no need to jot everything down right now. Just watch for that link when it comes out. The third QR code is to connect with your state's education advisor. We referenced that a couple of times for the questions. So everybody across the country here that serves Pittsco, we're all experts in this content and curriculum for robotics. So we'll be super excited and happy to help you. And again, just thanks for joining us today. And again, it's been recorded. This webinar has been recorded and we'll have that link out to you right away.
Yep. And if we didn't get fully to your answer your questions, we'll make sure to get someone in contact with you to follow up, to have a more in-depth discussion.
Perfect. Thanks, everybody.
Thank you.
Thank you. Have a great day.